welcome back. We're going to pick up where we left off in Objective 2. And our objective is to use the Pythagorean theorem or the distance formula to find the distance between points. So remember that the Pythagorean theorem is a squared plus b squared equals c squared. A and b are legs of the triangle, and c is the hypotenuse. All right, so we have two review examples for us. In both of these examples, we are given the legs, so we're given a and b, and we need to find the hypotenuse. So we would do 4 squared plus 8 squared equals c squared. So 16 plus 64 equals c squared. So c squared is equal to 80. And c, if we take the square root, is then equal to 4 root 5. And we'll leave it in radical form. For the second example, we do exactly the same thing. 6 squared plus 5 squared equals c squared. 36 plus 25 equals c squared. That's 61 when we add them together. We take the square root, and our answer is just the square root of 61 equals the hypotenuse. We can move this application of the Pythagorean theorem to find the distance between 2 points by literally counting sides again. So in this example, one side would be 1, 2, 3, 4, 5, 6. And then if we go over, it's 1, 2, 3, 4, 5, 6. So 6 squared plus 6 squared equals c squared. 6 squared is 36, plus 36 gives us 72. We'll take the square root, and we get 6 root 2 equals c. This example is exactly the same, so I'm going to skip over it. If you want to review it in class, please ask me, and then look at this one. The nice thing about this one is that we can just count down. 1, 2, 3, 4, 5, 6, 7, and the distance is just 7. We don't even need to use the Pythagorean theorem. The Pythagorean theorem does give us the distance formula. And I know that you've seen this review before, or this extrapolation before, so we'll just review the distance formula and say that the distance is the square root of x1 minus x2 plus y1 minus y2 squared. And we'll do 2 examples. I'll pick 6 and 8. So we just substitute in, we say d equals the square root of negative 2 minus 3 squared plus 1 minus negative 7 squared. 2 minus 3 is negative 5. Negative 5 squared is 25. So 25 plus 1 minus negative 7 is 8. 8 squared is 64. 25 plus 64 is 89. So our answer is the square root of 89. For number 8, we do exactly the same thing. We'll write d equals, to be sure that we're good with our notation, the square root 8 minus 5 squared plus 4 minus a negative 1 squared. 8 minus 5 is 3. 3 squared is 9. 4 minus negative 1 is 5. 5 squared is 25. 9 plus 25 is just the square root of 34. All right. right, the other thing we can do is find the traveling on the map, on the map grid. So let me scroll down. All right, so we can find the total distance by finding the sum of all the distances, and then the shortest is the distance between 2 points is a straight line. Okay. So again, I know that you've done this in Geometry A and that it's a review, so I'll just do one example. Say the first one. The first thing we want to do is draw the segments showing our trip. So we want to go 5 north. So we'll start at the origin and go up 1, 2, 3, 4, 5. Then 3 east, 1, 2, 3. 2 south, 1, 2, down 2. 3 east, 1, 2, 3, and 3 north, 1, 2, 3. And there's our final destination. Hopefully it's someplace warm. Okay. To find our total distance traveled, we literally count the number of steps we took. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. To find the shortest distance, we'll write the coordinates of this point, which are 1, 2, 3, 4, 5, 6, comma, 3, 4, 5, 6. Sorry about that, I got a notification on my device. So we have the point 6, 6. We have the origin at 0, 0. We'll use the distance formula and do 6 minus 0, because we're using the origin, squared, plus 6 minus 0 squared. All right, and that gives us the square root of 36 plus 36, which is the square root of 72, which simplifies to 6 root 2. All right, and then if we wanted to, we could do the second example. If you have questions about it, please ask me in class. If you have questions about anything else, also let me know in class or send me an email.